Okay children, in this video we are going to find the LCM of the algebraic terms. Now first example is we have to find the LCM of xy and xy squared. First thing is we have to write these two terms in this manner. පල්ලෙහාට මෙහෙම ලියා ගන්න xy and xy square. Now you have to write these given algebraic expressions or algebraic terms in index notation. xy, x into y, you have to write these numbers as a product. x to the power 1, y to the power 1. We can දීලා තියෙන ඒවා product එකක් විතර දිගාරින්න තියෙනවා. හැමදෙස්සම දිගාර index notation එකෙන් තියෙන්න ඕන. හරි? In here xy squared, there are two bases, x into y square. Don't expand y square. Y square දිගෑරියොත් වැඩි වර්ධිනවා. y square. Y square is in the index notation. එයා index notation එකෙන් ඉන්න නිසා ආයෙ මාරු කරන්නේ නැහැ. Or we can write x to the power 1. කොහොම ලියාගන්න? තේරුණාද? xy ලියන්න පුළුවන් x to the power 1 into y to the power 1. xy square can be written as x to the power 1 into y square. Don't expand y square because we want all the bases as the index notation. Now we can find the LCM. Then find the distinct factors. Distinct factors මොනවද තියෙන්නේ? වෙනස් bases මොනවද තියෙන්නේ? x and y. Then we have to find the largest, highest power. When we consider x, we can say highest power of x is x to the power 1. Highest power of x के බැලුවොත් තියෙන්නේ මෙතන 1 විතරයි. Then x to the power 1, or we can write x into when we consider the y, we can see there's a y to the power 2. Then this one is the highest power. Then we can write x to the power 2. So the y to the power 2. Now we can remove this multiplication symbol xy square. So LCM of xy and xy squared is xy squared. කියන්නේ xy squared මෙයාගෙනුයි දෙන්නගෙම බෙදන්න පුළුවන් පොඩිම ඉලක්කම තමයි xy squared කියන්නේ. හරි? තව එකක් try කරමු. Next example is 6, 3a and 8b. Now can you see there are some numbers. Numbers තියෙනනේ. In our previous video we discussed how to how to write these numbers as an index notation. Numbers දුන්නොත් index notation එකේ ලියන එක අපි කලින් එකේ කතා කරා. 6. 6 can be written as 2 into 3 is 2 to the power 1 and 3 to the power 1. මේක එකපාරට ලියන්න බැරි නම් බෙදලා ගන්න. 3a, 3 to the power 1 and 8 to the power 1. There's only 1a. 8, how can we write 8? 8 can be divided by 2, then 4, again divided by 2, then 2, 1. 1, 2, 3. 2 to the power 1, 2, 3. 2 to the power 3 into b to the power 1. Then LCM. Now we have written all the given numbers in the index notation. Now you have to find the distinct factors. වෙනස් factors හොයන්න. 2, 3, a, b. Now you have to find the largest power. When we consider 2, first we have to consider the numbers. මොනවද numbers දෙක බලන්න. 2. In here 2 to the power 1, in here 2 to the power 3. Then the largest power is 2 to the power 3. Then 2 is over. Then you have to consider 3. In here 3 to the power 1, in here also 3 to the power 1. Then largest one is 3 to the power 1 is same as 3. Then we have to move to the letters. A to the power 1, b to the power 1. A to the power 1 is a. There's no any other a terms. Then b into b. 2 to the power 3. What's the value of 2 to the power 3? 2 to the power 3 is not equal to 2 times 3. 2 to the power 3 is equal to 2 into 2 into 2. Ne? 2 to the power 3 කියන්නේ 6යි නෙමෙයි. 2 to the power 3 is 2 into 2 into 2 is 8. Or you can expand this. 2 into 2 into 2 times 3 into a into b. 8 times 3 is 24. We can remove this multiplication symbol, then we can write A, B. 24 AB. Therefore, the LCM of 6, 3A and 8B is 24 AB. Okay? Our examples there try karamu. Okay, now let us try another two examples. In here we have to find the LCM of 4m, 8mn squared, 12m squared, n squared. First thing is we have to write these three numbers vertically. 12m squared, n squared. Then what is next? Then we have to write all the numbers as index notation, and 4 can be written as 2 to the power 2. Bari ayata puluwan pallata bedala ganna 2 to the power 2. And m, there's only one m, then we can write m to the power 1. 8, how can you find 8? 8 is 2 to the power 3. Then m, there's only one m to the power 1. There are two n's, to n to the power 2. Then n square. Then this one, 12. How can you write 12? 12 can be divided by 2, then 6, again divided by 2, 3. Now divide by 3. 2 to the power 2 into 3 to the power 1. 2 to the power 2 into 3 to the power 1 times m squared, don't expand n squared digarin epa, n squared. Now what is the LCM? What are the distinct factors? 2 and 3, m, n. Venas saya 4 denek inනවා. Then you have to find the largest power. When we consider 2, the largest power of 2 is 2 to the power 3 times 3 to the power 1. When we consider m, highest power is m squared. When we consider n, highest power is n squared. 2 to the power 3 is, if you want, you can expand this 2 into 2 into 2 into 3 into m squared into n squared is 2 into 2, 4, 4 into 2, 8, 8 into 3, 24, m squared, n squared. So, LCM of these three numbers is 24 m squared, n squared. Then next example, ABC. 4 a squared b, 8 a cube b squared. ABC, nothing. ABC is a into b into c, or you can write the power index. 4 can be written as 2 to the power 2, a squared, b to the power 1. 8 can be written as 2 to the power 3, a cube, b to the power 2. Then what are the distinct factors? 2, a, b and c. Then what is the largest power of 2? Largest power of 2 is 2 to the power 3. Then a to the power 1, a to the power 2, a to the power 3. So largest power is a to the power 3. Then b to the power 1, b to the power 1, b to the power 2 is, then largest one is b to the power 2. Then c, only one c. 2 to the power 3 is 8, a cube. Now you can remove these multiplication symbols, b squared, c. So LCM of these three numbers is 8, a cube, b squared, c. Now you can do exercise 12.1.